The garbage collection registry is a subsystem responsible for tracking and managing memory reclamation events across the runtime. It maintains a hierarchical structure of collector instances, each with distinct lifecycle phases and configuration parameters. The registry does not perform collection directly but serves as a centralized coordination point for all garbage collection activities within the process. Initialization occurs at runtime startup, prior to any allocator instantiation. Registration of collectors follows a deterministic sequence. Each collector submits a registration request containing its type identifier, generation level, and collection strategy designation. The registry validates these parameters against predefined schema constraints before accepting the collector into the active roster. Duplicate registrations are rejected with error code GC duplicate collector. All registrations are written sequentially to the internal log. The registry maintains 4 primary data structures: a collector roster indexed by unique identifier, a generation mapping table associating collectors with heap generations, a trigger threshold table defining collection initiation conditions, and an event log recording all state transitions. These structures are updated atomically to ensure consistency across concurrent queries. Read operations do not require exclusive locks. Collection triggers are defined as predicates evaluated against runtime metrics. The default threshold trigger fires when heap utilization exceeds a configured percentage, typically 85% for young generation and 92% for mature generation. Time-based triggers can be configured to initiate collection at fixed intervals. Threshold values are stored with microsecond precision and evaluated at regular sampling intervals. The registry tracks collector state through an enumerated set of phases: initialized, active, running, paused, suspended, and deregistered. State transitions follow prescribed paths defined in the internal state machine. Attempting invalid transitions results in the error code GC invalid state transition. The state of each collector is persisted in the event log whenever a transition occurs. Metrics collection within the registry samples the following parameters: total allocated bytes per generation, current free bytes, total collection cycles completed, average pause duration in milliseconds, and peak heap utilization percentage. Sampling occurs at configurable intervals with default granularity of 100 milliseconds. Metrics are stored in a circular buffer with configurable retention period, typically 10,000 samples. The pause mechanism allows temporary suspension of all registered collectors without deregistration. Invoking the pause operation sets all collectors to the paused state and prevents new collection cycles from initiating. Paused collectors maintain their registration parameters and resume operation when the resume operation is called. The pause duration is not limited and may persist indefinitely. Query operations on the registry return current snapshots of registered collectors, their state, and associated metrics. The query interface provides filtering by generation, by state, or by collector type. All queries are read-only and do not modify internal state. Query responses include a timestamp indicating the snapshot age. Queries on deregistered collectors are not permitted. Event logging in the registry captures every state change, trigger firing, collection initiation, and error condition. Each log entry contains a monotonically increasing sequence number, an absolute timestamp, the relevant collector identifier, the event type, and optional context data. The event log is persisted to disk at configurable flush intervals. Log retention is controlled by age and size limits. Deregistration of a collector removes it from the active roster and transitions it to the deregistered state. All associated metrics and state are preserved in the event log for historical analysis. Deregistration does not immediately deallocate the collector object itself. Attempting to deregister a collector that is currently in the running state results in a pending deregistration status. Configuration parameters for the registry include the sampling interval in milliseconds, the event log flush frequency, the maximum age of retained metrics in seconds, and the maximum size of the event log in megabytes. These parameters can be set at initialization or modified during runtime through the configuration update interface. Updates take effect immediately without requiring restart. The registry provides a statistics aggregation operation that computes summary metrics across all registered collectors. Aggregated statistics include total heap size, global collection count, average pause duration across all collections, and the timestamp of the last collection event. Aggregation does not block ongoing collection activities. Results are valid for the moment of computation only. Error handling in the registry follows a consistent pattern. All operations return status codes indicating success or specific failure conditions. The status codes are enumerated in the error reference section. Critical errors such as internal data corruption trigger automatic logging and may initiate emergency shutdown procedures. Non-critical errors are logged and reported through the query interface. Concurrency control within the registry uses reader-writer locking to permit multiple simultaneous read operations, while serializing write operations. Read-only query operations acquire shared locks. State modifications, registrations, and deregistrations acquire exclusive locks. Lock acquisition times are tracked and contribute to internal timing metrics. Deadlock detection is not implemented. The locking protocol is designed to prevent deadlock through strict ordering requirements. The event replay mechanism reconstructs the complete state of all collectors at any point in the past by reading the event log sequentially and applying each event in order. Replay operations are read-only and do not affect the current runtime state. Replay is useful for debugging and historical analysis. The earliest replayable point is limited by event log retention policies. Shutdown of the registry follows an orderly sequence. All active collectors transition to the suspended state. The event log is flushed completely to persistent storage. The internal data structures are released. Any pending queries are rejected with error code GC registry shutdown. The shutdown process completes atomically. Subsequent operations return the shutdown error until restart.